Hello student, this is SAHA and today I discuss about probability. So probability is an important topic in higher mathematics. So I define first what is probability and then try to understand you and make you understood about the probability through examples. So let's start. Definition. Definition is very easy to understand. Its probability is denoted by P of any X incident or any set A which is measured by probability. You can say it is a function of A, probability function of a set A by set A is a collection of incidents, or you may say a collection of outcomes. A is a collection of outcomes. So total number probability is measured by a quotient. It is a total number of favorable outcomes, means which you intend to measure by probability. This is favorable. Total number of favorable outcomes. Favorable outcomes. And where your incidence takes place, uh, in which incident you are doing to take place, this the total outcomes of the incidence is the denominator. Total numbers of layers in total number of layers, total number of outcomes in message, total number of outcomes. So what does it mean? I am giving an example to make it understood easily. Take a coin. A coin have two results, either have head or either tail. So I am taking a coin. It must have two results. So take S is the basic set. Basic set means the total number of outcomes which can be. So the basic set. So I am giving this is yes. Head or tail. The outcome may be head or the outcome may be tail. So now I toss the coin twice, not once time, twice. Then what will be the outcomes? If I twice uh, toss the coin, then it may be then both the layers may be head, or one may be head, one may be tail. First outcome may be head, and second outcome it may be tail, or it may be that in the first outcome it is tail and the second outcome is head, or it may be that both the outcomes are tails. There are four possibilities, not more than. These are the maximum number of possibilities of outcome. Now, a intended incident is that we intend to find out the A is such an incident. It is defined that we will take the result when the second times we get hit. Second time toss, second times, second time toss result must be hit. We will take the incident. The second time toss must be hit. Toss must be hit. So you can look that all the outcomes does not have the second time hit. Just this is have second time hit and this is the second time hit. So there are two results, two outcomes which have our intention to bring out. So there are head hit. First time toss is not considerable. Just second time toss is considerable. Second time here I am getting head, and and one more outcome, tail and head. So two results we are obtaining. So what is the probability of A? Now the probability of A very easily calculated by this definition. The total of favorable outcomes is 2 and total number of outcomes 4. So 2 by 4. So ratio is 1 by 2. So it is clear now through this example that what is a probability of an intended incident. So this is clear now. And one thing you can look at, probability always lies between 0 to 1. It may equal to 1 if all the uh, if the incidence is a certain incidence, like that you are taking such a coin which have both side head. So it is a certain incidence, both side head. If you are taking a coin, if it has both side head, then you always get head. It is a certain incidence, then its probability is 1. So probability can be 1 for certain incidents but not be greater than 1, never be greater than 1, and other probabilities always lie between 0 to 1. Now probability is clear. I am now clearing some more topics of probability. Look this. Now we know from set theory that a very important real that number of members in A union A union B is equal to number of members in set A plus number of members in set B minus number of members in A intersection B. The minus is taken because it is taken twice in the union. You can look this through this diagram, Venn diagram. This is called. If you take this set A and if you take this set B, this is A, this is B, and the cross section area, this is called A intersection B. A intersection B. So you can very easily verify that If in A there is 5 members A, B, C, D, E, I am taking in A, B, C, D, E, A, B, C, three elements I am taking, and in B there are two elements, 1 and 2, and A intersection B have two elements, taking H and 5. Then you can look this that A have actually 5 elements. You can look that A, B, C, H, 5. 5 elements in E. So this will be plus 5 elements in E. And in B, the total number of elements are 4 elements. So actually B have all the elements in A intersection B, and A has the all the elements in A intersection B. So A has total elements 5 and B has total elements 4. But what is A union B? The number of elements, it will be 9. Total number of A union B. If you will take 9, then you can look this. These members are taken twice. If you will directly add A plus B, just only A plus B, then you will get 9. But these elements actually taken twice. There are 3 elements, there are 2 elements, there are 2 elements, 7 elements should be. But you directly add 5 plus 4, you will get 9. So that's why we need to subtract A intersection B 1 times. This is the reason. So I think it is clear now. So in probability, this theorem is also true in probability theory. So look this, in probability of two intended sets A union B is probability of A plus probability of B minus probability of A intersection B. I am giving an example to make it clearly understandable. How this is true and how we can calculate A union B. Take a very I am taking A now. Now again I am taking the coin. For a cube I am taking. A cube have six surfaces. So I am taking a cube which have 6 surfaces. Written by, this is the basic set. I am taking, this is 1, 3, 5, 6, and when a cube is thrown, then a toss is also tossed. A coin is also tossed. Then also I am taking a coin. A cube is thrown and a coin is tossed. Then its result may be the same. Set may be either head or tail. H, T. Now both the incidents takes place at the same time. A cube is thrown and a coin is tossed. Then what will be the basis of these two incidents together? Then we will get uh, first a cube is thrown and then A coin is tossed. Then we'll get 12 members. 6 multiplied 2. So we can get 1 each, 2 each, 3 each, 4 each, 5 each. This can be our rates of the if the two incidents takes place together, 6 each. Or it may be 1t, 2t, 3t, 4t, 5t, 6t. There can be 12 outcomes if the two incidents take place at the same time. So now we define two incidents. Now I'm erasing this. Two incidents. One incident, internal incidents or favorable incidents. We seek to know that A is an incident such that A is find event number. Event number will look on the surface of Q. Event number on the surface of Q and tail in the coin. Tail in the coin. And another incidence I am taking that multiple of three. One is multiple of 3, multiple of 3 and find the toss shows the point shows the face tail. Two incidents are taking A and B. Then what will be their say figure in expressed in through the outcomes in set. A will be even numbers and tail. So even number this is and tail this is. This will be A. This will be the member of A and this will be the member of A. So there are 2T, 4T and what are the members of B? The members of B will be multiple of 3 and T. This will be 3T and 6T just. Nothing much. 3T and 6T. Now we used to find out the union, the probability now of union A union B. Then what will be A union B? First, we calculate A union B. What will be A union B? A union B will be T dt 40 and 60. And what will be the A intersection B? A intersection B will be the 16 common. Uh, 60. So now we will find out the probability of all the measures. So probability of A, what will be? Probability of A have total number of members. You can look that there are 3 elements and the total number of outcomes what will be 12. So 3 by 12. This will be probability of A. So this is 1 by 4. Now what will be the probability of B? Probability of B will be total number of outcomes of B. This is 2. This is 2 and total number of outcomes we have already calculated. This that was 12. So this is 1 by 6. Now probability of A union B, what will be? Probability of A union B. Probability of A union B. There are 4 elements. So this will be 4 by 12 and this will be 1 by 3. And probability of A intersection B. Probability of A intersection B will be, this will be 1 by 12. 1 by 12. One member in the intersection. So now this is already calculated. The P A probability of A union B will be 1 by 3. It is already calculated. Now, if we wish to know that the theorem, the uh, formula I have already written, that probability of A union B must be equal to probability of A plus probability of B minus probability of A intersection B. Then this is true or not, we will find out this. Probability of A plus probability of B minus probability of A intersection B. Just we put, I put the values and calculate the value. It is equal to probability of A union B or not. So this is 1 by 4 plus 1 by 6 minus 1 by 2. The common denominator will be 12. The common denominator will be 12 and numerator will be changed by 3. Simple just is 2 minus 1. You can look that this will be 4 by 12 means 1 by 3 as we desire to do. This is 1 by 3. So it is equal to P A union B. A union B equal to probability of A union B. So this theorem is true, and you can very easily understand that through this example. In probability theory, examples are very important to understand what happens in probability. Mm, Examples clear, very easily clear the sense. So we are now very clearly find out that P A union B must be equal to always P probability of A plus probability of B, and one times in subtraction probability of A intersection B. This is proved. Now many things to prove in probability. I could not cover all the topics in probability. Just at the finishing time, I want to just discuss something, and in the next video I will discuss more about probability. Conditional probability I will discuss later. So you have already known the famous law of famous law in probability theory, probability of two incidents. If it can be taken three incidents, P union B union C, then what will be the result? As we know thus in set theory, it will be probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of E intersection C plus probability of C plus probability of A intersection B intersection C. Through a diagram you can very easily understand. You take uh, three sets this way. Then as I have already proved, in two sets. In the case of two sets, this is the case of three sets. PC. There, this is when you take all union of all the sets. This section union A intersection B, or this section B intersection C, or this section A intersection C are taken twice. So when you subtract this one time, you will get union P union B union C. But at the same time, this point P A intersection B intersection C is cancelled one times more. So that's why it should be added. So this is, I have said, A union B, A intersection B This is B intersection C. This is proved in the set theory. A intersection C. All are when you add a yeah, set A, set B, and set C, then all the intersections are taken twice. So that's why this should be subtracted. And at last, when you will subtract it, all this intersection from the addition, then you will get that, and the intersection of A intersection B intersection C is subtracted one times more. That's why we need for no, for pure calculation, we need to add A intersection B intersection. So this is a Venn diagram of the proof of this theorem. You will get this from the set theory, and it is also used in probability. So you can explain it in the case of n times of unions of incidences. So I think you like this video. At last, I will just say that if you like video, then subscribe this channel to get all the videos at the first time, and share with your friends. Must share with your friends. And you like or you don't like, must comment me. Subscribe. If you like, then share with your friends and comment me always. Comment me in YouTube box. I must follow your comment as you suggest. I must follow. Thanks. Thanks a lot.